we're going to now get into more specifics about the shapes. Okay, today we're going to talk about kites and trapezoids. Okay, so the first one we're going to talk about is a kite. Okay, a kite, we said, was a figure that has two sets of consecutive congruent sides. So these two would be equal and these two would be equal, but they're not equal to each other. Okay, if they were all equal to each other, it would be a rhombus. Alright, so when we draw the diagonals in a kite, okay, this is typically how you picture a kite, because you think of the flying kites and it has those diagonals in there for structural support. Okay, when you draw those diagonals, the main rule, or the first rule that you want to know, is that those diagonals intersect at a 90-degree angle. That's always going to be the case in a kite. Okay, so the diagonals intersect at 90 degrees. Okay, hopefully you can remember the word for that, our geometric vocabulary. Two lines that intersect at 90 degrees are perpendicular. Okay, now the next thing you'll want to know are the parts of the kite when we say specific angles. Vertex angles are the angles where the congruent sides meet. Okay, so when you look at a kite in this direction, it would be top and bottom, but a kite could be drawn on its side, so it wouldn't look like top and bottom, but it's where the consecutive sides meet. Okay, if you want to make a note that vertex angles are where the congruent consecutive sides meet. Okay, and then your other angles where the two sides that are not congruent meet, those are the non-vertex angles. Okay, so we have vertex angles and non-vertex angles. We know that the diagonals are perpendicular, okay, and you can see that it's broken this into 4 triangles. These 2 triangles on top will be congruent, and these 2 triangles on bottom will be congruent, because the diagonal from vertex angle to vertex angle bisects those angles. Okay, so the diagonals are perpendicular and the diagonals bisect the vertex angles. Okay, so in our picture we could mark that, showing if this angle is being bisected, that means this is congruent to this. Okay, same thing down here. This side would be congruent to this side. Notice these are not the same size. Vertex angles are not congruent, okay, but they are bisected, so they would cut into 2 equal halves. Okay, but the top vertex and the bottom vertex angle are not equal to each other. Okay, another note you want to make about kites is that your non-vertex angles are congruent. Okay, so this entire angle before we drew the diagonal, okay, is congruent. So the non-vertex angles are congruent. Okay, this diagonal though does not cut it equally in half. Okay, so vertex angles are bisected by the diagonal. Non-vertex angles are not bisected, but they are congruent to each other. Okay, I know this can be confusing. It's kind of a lot of information for one shape. But once we start to practice with it, hopefully it'll start to make a little more sense and you can recall it more quickly. So let's try an example with this information we know about kites. We're going to try and fill out all of the sides and angles of this kite. Let's call this point of intersection A, B, C, D, E. So here we're given that angle BCE is 40 degrees. And so we need to find these other angles. Well, we know that the diagonals of a kite are perpendicular, so that means this must be 90 degrees, which means this is 90 degrees, 90 degrees, 90 degrees. Okay, so all four angles in the center where the diagonals meet are 90 degrees. We can now use that to find some of our missing angles because we've created triangles and we know the total of a triangle is 180. So if you take 180 and subtract your 90 and your 40, you can get what's left. Okay, so 90 minus 40 is going to leave us 50 degrees. And we said that non-vertex angles are congruent to each other. So across from here, this would be 50 as well. Okay, we said that vertex angles are bisected. So this is cut in half. So this would also be 40. Okay, now we're told that this is 30 degrees. So this would also be 30 because it's bisected. Now this is not necessarily 50 and 50. Okay, these are not bisected, but we do have a triangle where we know 90 and 30, so that leaves 60 degrees. Okay, now for side lengths, we're given that this one is 18. It has 2 tick marks. So here, 2 tick marks must also be 18 feet. 1 tick mark is 8 feet, so this must be 8 feet. Okay, now on this one, our side lengths, we can go ahead and label this as 10 centimeters. Okay, but we don't know either of these. We do know the perimeter is 64. Perimeter is all the way around. So if I've used 20 centimeters, that leaves me with 44 centimeters to split evenly between these two. So divide that by 2, and each of these sides must be 22 centimeters. Okay, you can label your inside angles where the diagonals intersect as 90 degrees each. Okay, and we can use that using triangles to find our missing angles. So that would be 90 and 55 from 180, leaves us with 35 degrees. Okay, in this case, this is drawn on its side. So this is a vertex angle, so it's bisected, so this must also be 35 degrees. Okay, non-vertex angles are congruent, so this is 55 degrees. In these triangles, the bisect means that this is 36 degrees. Pardon the bell. Okay, now if we have 90 and 36 degrees, we add those together and subtract from 180, that leaves us with 54 degrees. Okay, and that's how you would solve for a kite. Now for a trapezoid, okay, you need to know the parts of a trapezoid, the sides that are parallel. Remember, there's only one set of parallel sides. Those are called your bases. You won't always sit on your base, okay, but the base is the 2 parallel sides. The other sides are called your legs. Okay, isosceles trapezoids mean that the 2 legs are congruent. Okay, so these 2 would be parallel, and these 2 would be marked congruent. Okay, in an isosceles trapezoid, if you draw the diagonals across your trapezoid, they are congruent. Okay, so the diagonals are congruent. That's only in an isosceles trapezoid. Okay, now the other thing you may need to know about trapezoids is if we have the midpoint of a trapezoid of each leg and we connect them, okay, that's called the mid-segment. Remember in triangles, when you went midpoint to midpoint, that's a mid-segment. Okay, so that's the midpoint there and the midpoint here. Okay, it will be parallel to the bases, so all 3 of these are parallel. Okay, and it's going to be an average of the length. Okay, so your mid-segment is parallel to the bases and average length of the bases. So we'll do an example here explaining that a little more. Okay, but before we get to those, let's look at angles in trapezoids. Okay, if you're given that this is a trapezoid, okay, and these are the 2 that are parallel, okay, what you need to know are that the 2 consecutive angles, okay, are going to be supplementary. So if you want to go back to this main picture, these angles added together will total 180 degrees. They are supplementary. Okay, so if that's the case, 180 minus 92 will give you 88 degrees. Okay, in this example, we are told that these are congruent, so this is an isosceles trapezoid. Okay, so if these two must add to 180, this would be 110 degrees. Okay, now, in an isosceles trapezoid, just like an isosceles triangle, if two sides are congruent, two angles are congruent. Your base angles will be congruent. So these would be congruent to each other, and these would be congruent to each other. So this one would also be 110 degrees. So again, if you want to go back on an isosceles triangle and mark base angles are congruent. Okay, so the two angles that are on the same base will be congruent to each other if it's isosceles. Now, here's the example finding the mid-segment. Okay, I told you it's the average. Okay, average is adding and dividing by how many they are. So 12.9 plus 5.5, okay, and there's two bases, so then we'll divide by 2. Okay, so if you add 12.9 and 5.5, you get 18.4, and divide by 2 is 9.2. So this length is 9.2. Now, a good way to remember this, when you're not asked for the mid-segment, you're asked for one of the bases, you can do a little shortcut and figure how much did I add to get from one base to the mid-segment. Okay, I did plus or minus what? Okay, so from 4.4 to 5.5, you added 1.1. So you will do that again. So we're going to add 1.1. So that would be 6.6. Okay? And that's it.